Good afternoon. I am Trevor Mead, a staff associate with the Green Parking Council. I would like to welcome you all to our webinar on solar canopies. This presentation is part of our continuing series of informational webinars to educate the parking community on various issues related to the implementation of sustainable technologies and programs in parking facilities across North America. If you encounter any technical problems during the presentation, please email Gretchen Brown at gretchen@greenparkingcouncil.org or send a chat message to the presenters. Solar canopies provide parking facilities with the opportunity to take part in the transition to clean energy. Today's presenter will provide us with an in-depth of solar canopies, as well as shine light on the value they present to the parking industry. In a few moments, our presenter, Mr. David Rowan of GPC affiliate partner, SOLAIRE Generation, Inc., will provide us with an overview of solar energy in the United States, information on the opportunity that solar canopies present, a breakdown of financial incentives available in the U.S. market, and an explanation of project finances. Our presenter will speak for 20 minutes. Please enter any questions you may have into the chat box located on the left-hand side of your screen. We have allotted 15 minutes at the end of the webinar to answer any questions and hold a discussion on how the industry can move forward with the information we have gained here. The webinar will run no longer than 1 hour. Without further ado, I would like to introduce David Froelich, Business Development Director at SOLAIRE Generation, Inc. David has been with SOLAIRE Generation since 2009. His 19 years of experience in executive management and operations and finance has prepared him well for his role within SOLAIRE Generation. David has served as president of Graysdale Fabrics, Inc., a 60-year-old textile company. He earned a BA degree from Tufts University and an MBA from Northwestern Kellogg Graduate School of Management. I will now turn the presentation over to David.
Thank you, Trevor, and thanks everybody for taking the time. I welcome the opportunity to talk to you about solar and parking and what SOLAIRE Generation has been doing for the last 4 years in this area. So our goal, our mission is to transform the ordinary into the extraordinary, and we are really dedicated to expanding the role of solar and other renewables and how they play a role in the world of energy in our country and in the world. I've got a little disclaimer here so that anything I say that is false or is not true, you can't sue me later. So let me just start with a little bit on who is SOLAIRE. So SOLAIRE Generation was founded in 2008 and by Lawrence Mackler, who came from a background in architecture, with the goal of using his expertise to expand the world of renewable energy. And we felt that if solar was going to continue to grow in its presence, then there would be a continued search for real estate and places to put solar. And the parking lot seemed like a great solution for that. Big open areas, very close by large buildings that use a lot of electricity, and areas that were already exposed to the sun because they're typically clear cut. So it seemed like a fantastic opportunity. We brought our designs to market in early 2009, and in 2010 we signed our first contract, which was with Johnson & Johnson for one of their facilities in Raritan, New Jersey. And so since then we've built over 28 megawatts of systems. Up on the screen you can see a select group of some of the companies that we have worked with or for. There are some Fortune 100s like Johnson & Johnson and Dow Jones and Munich Reinsurance, General Electric, some universities like RUTGERS, University of Texas Southwestern Medical Center, and some military work as well for the Marines and for the Army. Just a few things in terms of what we do. We design, fabricate, and install these parking structures. Typically we are working with solar integrators or developers providing the solution that they need for their parking lot. We have tried hard to combine innovation with industry-leading aesthetics. Our approach to the market has been that if people are going to be putting a parking canopy on their parking lot, a lot of them are going to care about more than just the least expensive way to do it, but they will also care about durability, quality, and frankly, aesthetics. People put a lot of money into their buildings, into the facades, into the landscaping, and we want to help enhance that. We don't want to detract from it. Our team of professionals has come from a construction background, and we have fortunately been able to meet the very demanding requirements of a whole range of customers from, as I mentioned, Fortune 100s to the military. And after having completed the 28 megawatts that we've done, each project has come in on time and on budget. Oops, sorry, I hit the wrong button. Still learning how to use this presentation. So 28 megawatts, what does that mean? That's the equivalent of about 8 miles of parking canopies, each one being about 40 feet wide, which would cover a row of head-to-head parking. Down below I mentioned a couple of little breakouts of that, including the fact that about 5 megawatts of that has been for the military, 8 megawatts was for Rutgers University, which happens to be the largest solar carport system in the United States. And as I had mentioned, we have a track record of delivering our projects on time and on budget. So just a few comments on solar. What is solar? Solar, photovoltaic solar energy is basically taking or converting sunlight into electricity. So that's a distinction between solar thermal, which is a method of actually creating steam for hot water. The PV is generating electricity, which can be used to run anything that electricity runs. Typically, photovoltaic cells are made of crystalline silicon. It is a very established technology. There are no moving parts, and it requires very little maintenance. This is a technology that's been around for decades, and so for a lot of people, they feel like, well, this is very new. I'm not sure how reliable it is. There's actually reams and reams of data of information on how very reliable solar electricity is. And it's just one strategy to reduce greenhouse gas emissions. Obviously, there are other renewables. We're big fans of all of them. We are focused exclusively on solar. In the U.S., PV is becoming an increasingly important source of electricity. As you can see, I mentioned that PV installations have doubled from 2009 to 2010 and again to 2011. A report came out very recently that talked about renewables representing, I think, more than half of all new power generation in the United States now. In the top 10 states I list here, California, New Jersey, Arizona, Nevada, Colorado, New Mexico, Pennsylvania, Florida, Massachusetts, and North Carolina. Those are the ones that are leading in terms of installed capacity. That is a constantly, well, not constantly moving, but there's always some changes in that as different states put into effect or take away different types of incentives, and solar has largely been driven by state incentives on top of federal. Just a quick map talking about where are the great spots in the United States to put solar. As you can imagine, the Southwest is particularly red, but the truth is solar works anywhere. The largest solar market in the world is in Germany, which is basically at a latitude north of or right around Nova Scotia. So there's, depending on the incentives at stake, every place in the United States generates enough electricity to make it work. It just depends on some of the other aspects of putting together a particular project, some of the financial issues. Other types of solar installations, ground-mounted arrays. When you read about large solar farms, they tend to be using large open areas for solar. And rooftop arrays. Rooftops typically the first place a building or a company looks for solar. It ends up being less expensive, and of course it's also very close to the building since it's on its roof. But there are some issues such as limited space. There are obstacles to contend with. I've got a little typo here. There's also the potential to void a roof warranty, not a solar panel warranty. But since you're putting stuff on a roof, sometimes there are issues with the providers of the roof. So why solar parking canopies? Frequently, there's a lot more space on a parking lot than there is in a roof. Usually we see a ratio of somewhere in the neighborhood of 4 to 5 times more more space available on a parking lot than there is on a roof. It's obviously also an opportunity just to expand beyond the roof. So if you've got 100,000 square feet on your roof, you might have 400, 500,000 square feet of parking lot, and depending on your needs, you can dramatically expand the size of your installation. You don't run into some of the rooftop issues like obstructions or leaks, and it can be installed without a loss of any parking spaces. Simply, you are transforming an underutilized asset into a beautiful power plant. It's still a parking lot. It's just a better parking lot. What you have done is you've improved the parking experience for your employees or your visitors, offering protection from sun, rain, and snow. It's a highly visible reminder of an organization's commitment to renewable energy. When you do a rooftop installation after the ribbon cutting, it's very hard for people to remember that there's actually solar up on the roof. When it's in your parking lot, they see it every single time they pull in. Plus, it provides some additional branding and advertising opportunities, and really an ideal solution for commercial, retail, or entertainment destinations. I keep hitting the forward button on my keyboard, and that does not work on this system. Some of the environmental benefits, the life cycle emissions of PV have been calculated to be about 40 grams of carbon dioxide per kilowatt hour produced, compared to 1,000 of coal. And in addition, the shade provided by Canopies reduces the internal temperature of a car sitting in the sun. If your car is cooler, you use less AC, either when you're idling, waiting for somebody, or when you get into your car at the end of the day. It takes less gas to cool that car while you're driving. Some additional benefits: on-site electricity production can save energy bills, resulting in long-term cost savings. Extra energy can, depending on where you are, can either be sold or can serve as a backup. It can serve as backup generation in the event of emergency. The Canopies offer the opportunity to collect rainwater for possible gray water use, such as irrigation, snow management, and enhanced safety with lighting and other electronics, such as surveillance or other safety measures can be integrated into the Canopies. So what's the market look like? As you guys all know, there are just lots and lots of parking spaces. So estimates between 720 and 2 billion parking spaces. If we take a 20% share of that number, let's say approximately 150 million parking spaces with parking structures would generate at least 12% of the annual demand for electricity in the United States. So what have we done, Solaire? I'm going to take you through a few of the projects that we've been fortunate enough to be a part of. We were chosen by Johnson & Johnson for 2 addresses in New Jersey to put up Canopies. They really wanted a robust and aesthetic solution with water management. They felt very strongly that if they were going to put up Canopies, they didn't want water dripping down through the Canopies onto their employees' heads. And they selected us because of our canopy durability and aesthetics. So at 2 different sites in New Jersey, we've put up about 4 megawatts of what we call our premium carport. That is a carport that has, as you can see in front of you, an integrated deck and gutter solution. So under the panels, you can see a white layer of decking underneath. General Electric, when they were preparing to do one of the early releases of their electric vehicle charging system, they wanted a solar canopy to integrate with that EV charger. We built a project with them, which was at the time the largest combination solar parking canopy with EV charging. That's at their industrial products headquarters in Plainville, Connecticut. Rutgers University, I mentioned, is the largest U.S. carport system. It is 8 megawatts. It supports 8 megawatts of solar. It is our Solaire 360 canopy, which does not have the integrated decking and gutter. As you can imagine, adding that layer of decking it's got a nice aesthetic feature to it, but it also carries quite a bit of cost. And the simple fact is that renewable energy projects at their heart are all based on economics. And so if the economics don't work, the projects don't work. I'm sorry, can I just ask you guys to hold 1 second? I'm going to take a sip of water. Thanks. So the RFP for that project insisted on many of the attributes that we include in our canopies, especially for regions where snow and ice are concerned. They wanted a dual incline design, and by that I mean the two inclines that actually make a sort of a V, so that snow and ice, instead of sliding off the canopy, will slide towards the center of the canopy where it will melt. Obviously, most people are concerned about that type of risk. A school in particular wants to make sure that they do not have snow and ice that can slide off the canopy at the wrong time onto somebody. In addition, we always have concrete piers coming out of the ground, minimum of 2 feet to protect the steel and also keep that base plate connection out of soil, water and other corrosive elements, which you find especially in snow regions during the winter. And then just a couple quick slides here on the Marines. We've built several megawatts for the Marines, both on ground parking lots and on the top of parking garages. This is actually a rendering of a project that we'll be building over the next couple of months. It is our long span solution, which is designed to cover the top of a multi-level parking garage. Here's an example of the first garage top system that we built. We finished this about a month ago for Staples headquarters in Framingham, Massachusetts. They wanted a system that was going to pretty much cover the entire top and also collect rainwater and protect their employees from rain when it did fall. And so this actually, you can't tell from the system, but it actually has a gutter system so that all the water will run down, go into a gutter system, will then come down through downspouts. Looking at my time, make sure I'm keeping up. So how does this work in the United States? So the federal government has a 30% investment tax credit for renewable energy projects. There is no max on that. This program is in effect through 2016, and hopefully will be renewed to go past that point. In addition, there are accelerated depreciation benefits, and when you take into account the investment tax credit and depreciation, you're looking at about 65% of the cost of a solar installation. In addition, state and local solar incentives, there are tax-based incentives, there are production-based incentives. There's not enough time for me to kind of go into all of these details. I'm certainly happy to walk people through particulars of these in certain states, but there are basically a variety of methods by which states or utilities are offering people incentives to put in renewable energy. Just a couple maps here of kind of where solar taking place. Where you see these circles tend to be the states in which there have been incentives that have made it worthwhile for people. You can see the Northeast and California kind of leading the charge. Corporate America understands solar. You take a look at some of the names on this list, and you can see that a lot of companies that we are all very familiar with have already made large inroads into generating renewable energy. They typically started with rooftops. We believe there, even for all of these guys, there's still ample opportunities for additional capacity on their parking lots. So just a couple quick examples of a northeast and a southwest potential parking project. This is a regional airport in New England where we would cover about 50% of the lot. It's hard to, I don't want to spend too much time on the numbers, but in some regions there are something called a feed-in tariff, where instead of using the electricity for the host, you actually are selling the electricity generated to the utility for a fixed rate. That is the method that has been used very successfully in Germany and other European countries, and we've seen it in a few areas here in the United States. For numbers, we are assuming that the parking operator has charged a slight premium for covered parking, has provided some EV charging services, and also is available to sell space for advertising. We're talking about a 500 kilowatt system that would cost just south of $2 million. We cover about 200 vehicles, generate about 540,000 kilowatt hours a year, and then you can see there's some benefits, the equivalent of how many homes that's equivalent to or cars taken off the road. So what do the numbers look like when you've got the stars aligned in terms of incentives and some additional revenue? This is it's a complicated slide, and again, I'm happy to work with the Parking Council to follow up with individuals on how to take you through the details. But the idea here is if you're financing half of the investment, that over a 20-year period, you're going to be looking at an internal rate of return somewhere around 19–20%. And that includes the idea that you are generating additional parking revenue from, here we're assuming that 25% of the space that is covered, that you've got people who are paying additional for that parking. In addition, there is a the feed-in tariff incentive. Again, that's 22.5 cents. So that's very similar to what you might see in Rhode Island, who's had a periodic feed-in tariff offering, and that's roughly the kind of numbers that they have been paying for electricity generated. The Southwest, higher. This is a parking deck, obviously higher production in the Southwest. So for a similar 500 kW system, now you're looking at generating 750,000 kilowatt hours a year. Again, so you can see how that compares in terms of the number of cars taken off the road, and what the numbers look like here. So here we don't have any other revenues. This is somebody who's only selling their electricity back to the utility at 17 cents. This is the rate that the new Los Angeles feed-in tariff is at. And so it's 17 cents an hour, kilowatt hour. We're assuming no other revenues. And what you see here is even with no other revenues and at the lower incentive, you still have an opportunity for an investment that would generate a 10% internal rate of return. And there, I flew through it. It's 2:24. I believe I was handed the microphone at 2:04. And so I guess it's now time for questions.
Sure. Thank you, David. Our first question is there a general rule of thumb for estimating the size of a system? If I have a garage with 40,000 square feet, about how many kilowatts would that produce?
Sure. So I guess I'm going to give you two methods of estimating. If you are talking about a multi-story parking garage, you take your square footage and multiply it times, let's say, 13. 12.5 to 13, which is the number of watts per square foot. That's an average number. As you can imagine, this could vary by the type of panel. There are a lot of different panels out there. Some are higher efficient, some are less. There's also, depending on where we're building, what kind of tilt we have, how much room we need to leave for shading between panels. But 12.5 is a pretty good number to multiply times the total amount of square feet available. As you can imagine, there's also issues like sometimes elevator towers or stairwell towers cast shade or nearby buildings. So a lot of things to take into account, but that's the best way of estimating. If you're looking at a ground parking lot, then what we find is there's about a 2-to-1 ratio. If you're looking at a row of what we call head-to-head parking, so about 2 9x18 parking spots facing each other, so 36 wide. If we build a 40-foot canopy, which is our standard canopy width, over that row, for every 100 feet, every 100 linear feet of parking or of canopy is about a 50 kW system. So that's about a 2-to-1 ratio.
Okay, thank you. The next question is, how do you design to avoid wind issues on top of, for instance, an 8-story parking garage?
Well, I'll tell you. So an 8-story parking garage is a pretty challenging design. I would say the highest that we have designed for at this point is just a 5-floor garage. One of the challenges about building on top of parking garages is that all the lifting has to be done from a crane on the ground, because these garages are not built to take the wheel load of heavy vehicles. Even if you could get them up to the top of the garage can't support them anyway, or most garages can't. And so And so everything has to be done by crane. If you are talking about an 8-story parking garage, you need that much bigger crane. So we really need to look at the specific opportunity just to make sure that the economics aren't going to be thrown totally off by the equipment needed to build. That being said, all of these parking canopies are designed kind of in the same way buildings are designed, that they have to meet all local wind, snow, seismic requirements. And so as those loads increase, either the frequency of our steel members increases, the number of columns we have to use, or the size of the steel members has to increase to handle larger loads. So for example, the project we saw at the Staples headquarters, that 55 pounds per square foot snow load, very high snow load. Prior to that, we had not built a canopy for more than 30 pounds, and so that was a significant increase. We've built projects down in Florida to 150 mile an hour wind loads, not on top of a parking garage, but on a ground load, so still, obviously to meet the requirements for a hurricane zone. So it depends, but everything has to be engineered as if it were a building, so that the local building department can approve it.
Thanks. The next question is, what is the 50% bonus on accelerated depreciation?
It is basically taking, so MAKERS is the abbreviation for it. Hold on one second. I believe it's 60% in the first year. So it's shifting the allotment of the depreciation forward, and I believe it's 60% in the first year, 64 in the first year, and then the rest over the remaining 4.5 years.
And then another question we had was, what does the financing look like for a governmental unit such as a transit district?
So anytime you have a situation where a company that is not a taxpayer, the typical solution you see with solar is to have a third party come and purchase and own the system and set up what's called a power purchase agreement with that organization. And so instead of having the organization own the system outright, the third party owns it and takes advantage of the tax incentives and signs a contract to sell the electricity to that organization at a fixed rate, which may or may not increase over time, but an established rate over anywhere from a 15 to a 25-year term. And then at the end, very often there's a flip or a buyout at some type of predetermined fair market value. But the way non-taxpaying entities can take advantage of the tax incentives is through third-party ownership for people who will take that advantage and then sell the electricity to the entity.
And then for an average carport project, how does the payback period compare to a rooftop installation? Well,
so it's longer. It averages a really hard word because I'm not sure what the average is. So when we had $650 renewable energy credits in New Jersey 2.5 years ago, you were seeing 1 and 2 year paybacks on rooftops and 3 or 4 years on parking canopies. But now those incentives have largely gone away, and so those are probably 3 times that now. It's longer, but it's hard. I would say on average probably a year or 2 longer. But so the one thing that I'd just like to point out that parking canopies are more expensive than rooftops. But when you take into consideration the fact that, and I would say, let's say on average 75 cents a watt more expensive. But when you take into consideration the fact that you have 30% investment tax credit plus the accelerated depreciation, you're probably looking at an increase of, let's say, 35 cents. And what we believe, and again, this is still a relatively new industry, is that when you take a look at the costs of maintenance and other issues that are related to rooftop versus your parking lot, over the next 20 or 25 years, that cost actually it ends up not being more expensive, or not noticeably more expensive. For example, if 15 years from now you need to redo your roof, the cost to remove that solar installation and then put it back in, as opposed to anytime you want to repave your parking lot, you can still do it with your parking canopy there. So, but very often what people do when they are looking at solar projects is they are only looking at the cost on day one. I feel like they don't spend enough time thinking about a lifetime of O&M.
Our next question here is, has your company placed panels on the side of a multi-story parking ramp that will move with the sun during the day?
We have not. No, so there's a growing segment of the solar industry called BIPV, which is Building Integrated PV, and so I think you will see more and more of that. We haven't. We've really been focused on structures on the surface of lots to collect solar. We've also focused exclusively on what we call a fixed tilt canopy, and so we do not have canopies that track the sun. They are, I think, really interesting. They are also, as you can imagine, more complicated and end up with certainly a more complicated and more expensive maintenance program, because you've got moving parts in a way that our canopies, once you've put them up, there's nothing moving.
And that's all the questions we have right now. So I'd like to thank our expert presenter for taking time out of his day to educate us on this topic. The knowledge he has shared has helped the parking industry to gain a greater understanding of solar canopies and the opportunity they present for our operations. As of tomorrow morning, this presentation, as well as our panelists' contact information, will be available on the Green Parking Council website. I encourage you to reach out to David with any additional questions you may have. Our next webinar, focusing on the integrated approach taken to build the N-Rail garage, will take place on February 14th at 2 p.m. Eastern. We encourage you to sign up for our newsletter at greenparkingcouncil.org to receive information and updates regarding future webinars. If you have any suggestions for future webinars, please email me at trevor@greenparkingcouncil.org. Thanks for joining us.
Thank you, everybody. Appreciate your time.